With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, in the reaction N2 gas plus 3H2 gas gives 2NH3 gas, the value of the equilibrium constant depends upon. Now, the value of the equilibrium constant, which is represented by Kc, it does not depend upon the concentration, neither on the pressure, nor on the mole. It only depends on the temperature, right? It only depends upon the temperature. The relationship of equilibrium constant with temperature is given by the Van 't Hoff equation, right? This is given by the Van 't Hoff equation, which shows the temperature dependence of the equilibrium constant, right? That is given as ln K2 by K1, where K2 represents the equilibrium constant at temperature T2 and K1 represents the equilibrium constant at temperature T1, right? And this is delta H divided by delta H divided by R, right? This will be delta H divided by R, 1 upon T1 minus 1 upon T2, where delta H is the enthalpy change, R is the gas constant, and T1 and T2 are temperatures, right? So this is the relationship that gives the relation between the equilibrium constant and the temperature, right? So this is the equation that relates the temperature with the equilibrium constant, right? So for example, you have an exothermic reaction, right? For example, if your reaction is exothermic, it means that the delta H is going to be negative, right? The delta H is going to be negative. Now, for an exothermic reaction, according to the Lee-Chatelain principle also, that according to the exothermic reaction, when the delta H is negative, if we increase the temperature, the reaction goes to the backward direction in order to oppose the change and maintain the equilibrium, right? So it shifts the equilibrium in the backward direction. And if the temperature decreases in an exothermic reaction, the reaction moves forward, right? So even according to the Lee-Chatelain principle, when the reaction is exothermic, on increasing the temperature, the reaction becomes backward. On decreasing the temperature, the reaction becomes forward, right? So suppose we are decreasing the temperature and the reaction is becoming forward, it means that more and more product is going to get formed. When more and more product is going to get formed, and if we write down the equilibrium constant expression, that will be NH3 square divided by N2 divided by H2 cube. So as more and more forward reaction is taking place, the concentration of products is going to increase and therefore the Kc is going to increase. So this is how the equilibrium constant is affected by the change in temperature, right? For a given reaction, it depends upon whether the reaction is exothermic or endothermic, right? So accordingly, we have the relationship between equilibrium constants and temperature, which is majorly given by the Van 't Hoff equation. So the equilibrium constant depends only on the temperature, and that's the correct answer. It does not depend upon the volume, neither on the pressure nor on the concentration or the moles, right? The correct answer is option 4. That's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.